Boom! Yes, folks, Hume here again. So we in the final video on Pythagoras Theorem as far as talking, as far as explanation is concerned. If we do anything more, it will just be examples to illustrate stuff. But for now, this is the final video by way of explanation. In this video, we're going to deal with one of the aspects of Pythagoras Theorem that I really like to teach. I really enjoy teaching this. Right? It's not really a whole set of explanation to do, but it is always nice to pass on this knowledge to people, to students and whatnot. Right? This, strangely enough, is one of my fonder memories of being in school, learning AdMaths, right? Learning this topic. And again, it wasn't as if we had a whole class to do this. It's very simple, very straightforward. But something about it is just a nice spark. It's a nice thing to know. It's a nice thing to be aware of. So, what is a Pythagorean triplet? Now, nowadays they call it Pythagorean triples. I learn it as Pythagorean triplets, and I stick in with that. Right? To me, it just have a more Pythagorean sound to it, you know. But if you want to say triples, that's up to you. No problem with that, right? What is a Pythagorean triplet? A Pythagorean triplet is simply a trio of integers that conform the Pythagoras theorem. That is all it is. Right? Remember, in the preceding videos, we would have discussed the fact that in most cases, you would have at least one, sometimes two, sometimes all three side lengths as integers to deal with. Right? As a matter of fact, you could construct any right angle triangle. Right? But by its very nature, what would happen if you do that is that you will invariably get decimals somewhere along the line. However, there are certain trios, certain triplets of integers that do conform the Pythagoras theorem. You don't have to design anything. It is just there. You come here and you meet that. Good? So, examples of Pythagorean triplets. Now, there are an infinite number of Pythagorean triplets. Right? It is something that you could continue constructing as long as you care to construct it. Right? You could continue, not constructing, you could continue discovering Pythagorean triplets as long as you care to go on. So in other words, as the numbers get larger, it just never stops. It just never ends. You keep going and going and going, and then get Pythagorean triplets with larger and larger numbers. However, for most intents and purposes, you wouldn't need to know the big ones, right? It have computers and things for that. Internet and thing, Google and thing. Right? It have formulae and thing for that. Good? But it is always nice to know the small ones. And of course, we would have done the very first one in either the first or the second video. The 3, 4, 5. So you will commonly hear people talking about a 3, 4, 5 triangle. In some books, you'll see them represented as a 3, 4, 5 triangle. That is how people mostly describe it. Right, then there's another one. We have the 5, 12, 13 triangle. That's another classic case of Pythagorean triplets. Then you have the 7, 24, 25 triangle. You have the 8, 15, 17 triangle. These are the 4 simple ones, right? And then there are a couple more that I will put out here. Again, just for the sake of passing on simple knowledge. You have the 9, 40, 41 and the 11, 60, 61. Yes, I don't remember them all the time. But the 3, 4, 5, 5, 12, 13, yeah. Those are the 2 most common ones. And a lot of times you would see questions in a multiple choice where the calculator is not an option. You might get a right angle triangle where one side is 5 and the other side is 12. And they ask you to find the hypotenuse. So for example, in a multiple choice, you might get this, right? You might get 5, 12, and they ask you to find the hypotenuse. Now, this is one of those cases where if you don't know something, you could slug your way out and get the answer. It will just take you more time. Time that you could save if you had the knowledge. So for example, if you have the knowledge of a 5, 12, 13 triangle, then as soon as you see this, you know instantly that the hypotenuse is 13. How long did that take? 5 seconds the maximum. Alright? So in a typical multiple choice in CSEC maths, for example, where you would normally have 90 seconds to do a question, if you have that knowledge, you can save about 80 seconds in that question that you could use in another question. Right? Similarly, you might get a triangle like, let us say, you might get a triangle where this is 25, that is, this is 7, and then they ask you to find this length here. Right? Of course, you know that if you have any awareness of the 7, 24, 25 triangle, you know immediately, as soon as you see this, that the only thing that this could possibly be is 24, if this is a right angle here. Alright? Of course, if it's not a right angle triangle, then that is a horse of a different color. But once you have a right angle triangle and two sides, you have one side is 7 and one side is 25, well, then you know the next side is 24. Good? Etc., etc., etc. So in other words, and the thing about it is that there will be questions in a paper 2 format as well, a long paper format where you'll get a triangle like this. So for example, in a paper 2 format, you might get, this is the one that you will see a lot. You'll get a right angle triangle where you'll get the hypotenuse is 10, and you might get the base measurement here as 8. Good? Now, if you have a knowledge of the 3, 4, 5 triangle, you know immediately that this has to be 6 here. And why do I say that? Right? The reason why I say that is because 3, 4, 5 being the base, right? The base triplet, 3, 4, 5. If I multiply this whole triplet by 2, I will get 6, 8, 10. Alright, so in other words, 2 into 3, 4, 5 is equal to 6, 8, 10. So, in other words, you know the basic Pythagorean triplet, and anytime you multiply that by a positive integer, you'll also get a Pythagorean triplet. And if you want to work it out just to be sure, let me check it out. Right? By Pythagoras Theorem, we know that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So, check it out. 6 squared is 36. 8 squared is 64. 36 and 64 is, boom, 100. 10 squared is 100. And of course, we could multiply by any multiple. So, let us say 3 by 3, 4, 5 will give us a triangle where the sides will be 9, 12, and 15. 3 3s are 9, 3 4s are 12, 3 5s are 15. We can check it out again. 9 squared is 81. 12 squared is 144. Alright? 81 and 144 is how much? 144 plus 100 is 244. 244 minus 19 is 225. 225 is the same thing as 15 squared. And you could just go on doing that for as long as you care to do it. So let me try one of the others. Let us say we have the 8, 15, 17 triangle. The 8, 15, 17 triangle, so we say 2 by 8, 15, 17 is equal to 16, 30, and 34. Right? So we'll need a calculator for this. So the square of 16 is 256. The square of 30 is 900. And the square of 34, based on what we see in here, is supposed to be, what, 1156? 1156. Let me check it out and see. 34 squared. 34 squared is equal to, yes, 1156. And we could go on and on and on. So, with that, we could wind up this video by simply giving a brief list of the first 5 or 6 basic Pythagorean triplets. that you would need to know. It will make a difference. And these are the little things that if you take your preparation seriously enough, you wouldn't have to cram these things. You do enough questions, you take the time and learn it, and you make sure it stick. You go in the exam and you see a right angle triangle like this. You don't have to then go and say, well, 10 squared is equal to 8 squared plus a squared. No, because you know that's 6. So that even if you take the approach of writing out the working for the purposes of communicating to the examiner, you don't just want to just drop an answer on the paper. You do your working, you know the answer already. You know the answer before you start to write. So you could just run through it very quickly and move on with the rest of the question. So to wind up this video, we're going to present a few of the Pythagorean triplets. Alright? So one triplet, the very first one, which most people would meet, would be 3, 4, 5, and we put a k on the outside. This tells us that we can multiply any constant, any positive integer k by 3, 4, 5. The next one will be k into 5. Wait, I need to manage my space properly here now. Alright, so we start over k into 3, 4, 5. We have k into 5, 12, 13. We have k into 7, 24, 25. We have k into 8, 15, 17. We have k into 9, 40, 41. And we have k into 11, 60, 61. This is as far as we need to go for our intents and purposes at this point in time. For the most part, for most examining bodies where we examine students up to Form 5, that would generally be 16, 17-year-olds. Good. And of course, we have the more mature students who do the exam for whatever reason, and that is fine. Right? I want to take a little detour here just to encourage my mature people, my adults. Don't be intimidated because you're doing an exam that people doing in the teens. That's alright. Those same teens will discover as they get older that life is not always a linear thing. Life is not always a straight line. Right? Sometimes for a whole host of reasons, people end up doing something a little later in life. That is fine. Nothing wrong with that. Don't beat up yourself. Don't feel a how. If that is what it is, that is what it is. The most important thing is that you give it your all. Give it your total effort. Alright? So whatever age or stage you are in your life, if you're doing this, do it properly, do it well, give it your attention, give it your focus, give it your time. Right, so we continue. So generally speaking, for exam purposes, the most triplets that you will need would be 1, 2, 3, and 4. Right? These two, I just put out just to demonstrate the fact that we could go on and on. So we could have plenty more we could add on to this. And if you're curious enough, you could go on Google and type Pythagorean triples or Pythagorean triplets, and you'll see a number of pages would come up. And you'll see some pages where they go a little deeper into it to show you just how many of these things there are. Alright? So 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17. These are the ones that you should commit to memory if you have to memorize any. 1, 2, 3, 4. These two is just extra. what we refer to in Trinidad and Tobago as lanyap. All right, 9, 4, 41 and 11, 60 and 61. Of course, it must be noted that, and we're going to change the color of the ink here now. Okay, yeah, we change the color of the ink. It must be noted that we can't leave this out at all. K is a positive constant. Right? I use a different word here deliberately so you get a little more exposure to the language of mathematics. There are some times when we refer to it as an integer. There are some times when we refer to it as a constant. Integer, constant, constant, integer, same thing we're talking about. Alright? So, now, sorry. In fact, let me correct that. Shouldn't even say constant, I should say integer. Because it could be a constant without being an integer. Eh? So, and I'm sure some of y'all listening were actually thinking that. Right, so I have to correct myself there. So K is a positive integer, not a positive constant. 2.3 is a constant. Pi is a constant, and we know pi is not an integer. But we'll deal with that with more frequency when we're dealing with circles. So this is it. That is all there is. Right? Pythagoras Theorem is a beautiful topic. It is a nice topic. But like so many other topics in maths, sometimes people don't get it. So it is my hope that this series of videos on Pythagoras Theorem would have helped in that regard. And if it had helped, if these videos have been of help to you, then share it with somebody else who you think would need it. Right? And then the next step, of course, would be to do the work necessary. Whether you come in my platform or you do the work somewhere else, that is not the point. The point is get the work done. Of course, I have my platform where you could come and get the work done. So you'll have the videos, you'll have questions, you'll have solutions. And there will also be the opportunity to interact with me or to interact with other people on the platform as well. So that's basically it, right? So come on, stay in the game. Let me enjoy this maths. Good. So stick around, keep watching. We have plenty more coming your way.